Hello guys, very good evening. Can you guys hear me? Can you guys hear and see me? Let me know in the chat. Thank you Divikanta for responding. Thank you Arad. So how you guys are doing? How was your day? Very good evening Joseph. Very good evening Divikanta. So how was your day guys? Yeah, it was nice for me also. It was great. Very good evening Nishant. Nice, nice. So have you guys practiced any of the Q's problem or anyone has practiced LRU CAS? Tried to think about it. Nobody? Nobody has practiced? Very good evening, Ankit. So as I was asking guys, anyone has practiced Q's problems? Oh, that's not good actually, Nishant. From I think last 2 3 classes, I'm continuously saying that do not practice any other topics. Practice only stack and queues problems because these type of problems are going to help you a lot. There are a lot of problems which you guys will see which are going to solve with the helps of stack and queues. Lot of problems, even lot of graph problems, like mostly all of graph problem. Yeah, I think all of graph problems they simply solve with DFS and BFS. You guys know about it? Or most of the I will say most of the graph problem people solve it with the help of DFS and BFS. And in DFS and BFS we only use stack and queue. So guys, if you guys are practicing any other topics, it's not good. You guys are, I would say, missing the gem. In everything there is a gem which is like top of all other, top of rest. So that's what I think I will keep stack and queue on the top of rest. So if you are trying to solve, if you understood how to solve stack, how to solve problem with the help of stack and queue, then I think you guys will be solving a lot of different problems also. Ankit is saying, I have an internship. Should I join? Why not? It's nice opportunity actually. You will definitely learn a lot of things like on the programming basis. But tell me, we can chat about it, Ankit. You can connect to me on LinkedIn about it because I think while choosing any internship, it's great actually if you're getting chance to join it. But let's just look for the organization and what are the project, because I believe in internship I think it goes for 2.5 months, right? 2.5 months. And so just see what type of work they are going to give you in internship, because if you're not aware of that and they are just asking you to come and create HTML pages or Excel sheet data or some of the testing things, that would not good, right? That will in some way it will just decline your skill level. So that's what I actually you need to think about it. And if you're getting internship, I think yeah, you're getting good from the good company and from the good work also. Totally take it. Very nice time to take it. Okay, guys. So I think now most of the people have joined. So, so let me just repeat my question again. Anyone has tried the LRU CAS part? Because that was the topic which we have left after understanding the logic part. So anyone has tried any LRU CAS? Tried to implement LRU CAS? So looks like no one has tried. They were all practicing the older question. That's fine. So let's jump into that one quickly to complete the LRU CAS first. Okay. Are you guys able to see my screen? Thank you, Vishal. So yeah, this was our topic, LRU CAS. So we already aware of how the LRU CAS work, right? In the last call, if you guys just remember it, let me just quickly repeat it, how the LRU CAS work. So in LRU CAS, we simply have one limited memory, like memory or capacity, whatever we want to say. So we have some limited size or capacity or memory, and in that limited space, you need to keep some of the elements. Correct. So let's quickly draw it also. So this is our like LRU CAS memory, we can say, which the size is 4. Size is 4. Yeah, I think I have chosen the 0.25. That's why it was very thin. Okay, so let's divide this one. 1, 2, 3, 4. Okay. So now if we have some elements, so we will start putting it. So there was two methods, right? If you guys remember it, there was two methods. One was put and second was get. Right, guys? These were the two methods. And with while we are using the put method, we simply pass two things here. So first we pass the key like 4 and then we pass the value here. I'm just simply writing A as a value, correct? And then later on in the get method, we just pass the 4 and we get the value here, correct? That's what the purpose of cache memory. We will keep some of the data in the cache memory. And whenever we want to find it out, we'll just simply use the get method and get that data, get that data from the cache memory. Okay, that was two methods. After that, what we discussed in this cache memory, there are one strategy which we need to follow, correct? And because the cache memory size is limited, so you can see the capacity or size, whatever you guys want to say, this has 4 size. So at a time, it can only keep 4 elements here. So like I would say the key 8 is coming, or like A is coming, B is coming, data. I'm just talking about the data A, B, C, D. Now 4 elements already available in this cache memory, and now if we are trying to put E as well, so we need to remove one element from here. Then only we can keep the E here, right? And then what we talk about, how we will remove it, we will check whoever has not been used recently, whatever element has not been used recently, we will remove that element. So I can say if I have inserted A first time, and after that, if I have not used A after these operations, so I think A is the one who is the least recent used, right? So that's why we will remove A and put E here, correct? And we'll put E here, correct? Now E would be the first element who has been used recently, correct? Who has been used recently. So now if we got new element, put 8 and F as an element, so we will be not removing E now. We have to first remove all remaining first. If we are not using any of the elements, so we will be removing the next B, next C, next D. Everyone understood? That's what we discussed in our last class. Till now, any confusion? Any confusion at all? No, right? We are good. Already covered these things. Okay. So now let's today try to implement it. So if you guys remember, we were talking about we will be taking the DQ here, right? Because in the DQ, we can perform insert, delete from both sides, right? We can in DQ, we can do the insert and delete operation from both sides. Then we talked about we will also take one hash map here, right? I will tell why hash map will be good. But first, let's come back to DQ only. In that DQ, I told you we can implement DQ with two ways. One is array and second one is the linked list. Correct? Then we decided that if we want to reduce our time complexity, only talking about the time complexity, then in linked list would be better. And also in linked list, double linked list would be better. Because in double linked list, we have previous and next key or arrows always with the node, because see, in linked list, what is the problem? If you have head, if you already have tail, then I think insertion and deletion, if somebody wants to do insertion and deletion on head and tail, that those operations will always be in the constant time. Everyone agrees with that? If we want to do insertion on deletion or on head or in tail, always that will be constant, right? And that's what happened in DQ also. In DQ, we can do deletion and operation from two sides only. One is the front and second one is the rear. Same way in doubly linked list, we can do insertion and deletion from two points, and those 2 points are head or tail. Correct? And all the every time, if we are doing any insertion or head or deletion on a tail, those operation will always be constant time. Everyone agrees with that? Anyone has any doubt on that? I'm just right now talking about the insertion and deletion operation on doubly linked list. And I'm trying to relate that with DQ also. Everyone agrees here? Let me know in the chat. Agrees? Yeah. Okay, let me see. Vishal has one thing. So deletion on tail side would be O1 or ON. It will be O1 because you already had the tail there. You already have the tail, Vishal, and in the tail node, you will always be having the previous node as well. I'm talking about double linked list. In double linked list, Vishal, in double linked list, if we have two nodes, right? Just no problem, because this is important to understand, because today our topic is also linked list. So how the double linked list work? This arrow goes here and this arrow goes here. Then this will be pointing out to null. So this would be our tail. So if we want to insert something here or want to delete something here, we already have previous connection. So we do not need to traverse it. So that's why insertion on deletion on tail will always be O of 1. Same goes for head, O of 1. Understood, Vishal? Yes, if we do not have tail, then definitely we have to go for ON. Yes, only if two nodes are there. No, if there are more nodes also, then also the head and tail will always be at the same position. But if it were double circular one, if it will be a double circular one also, Vishal, still it will be constant time. In the double circular one, we only have one pointer, tail. Okay, visualize it, visualize it. You see, if we talk about the circular one also, so if we take like one more element, let's take one more element here. It's just visualization, guys. Okay, and this would be our tail, right? In circular one, we only take one pointer, which is tail, and this will be looking like this, right? Always the connection will be like this in double linked list. You guys remember that? This is the connection. Now this will be our tail, this will be our head. So now it's again, when you have tail and head, then you do not need to find anything. When you already have tail or head, you do not need to find anything. You can directly go to those pointers and simply do the insertion and deletion. Everyone agrees with that? Because you have head and tail. I think Joshua Bear understood correctly. If we do not have tail, then we need to traverse it. We need to find it. What is the last element? In those scenarios, we will be going for O of n. But if we have head and tail, then it will always be constant time. Now everyone understood? Just visualize it. Whatever we have read in the linked list, just visualize it for some time, some minutes. Just take some minutes and just visualize it. Bring all of that which you have read in, which you have put in your hard disk. Bring it to the cache memory or in the main memory. Totally right. Okay. See, the problem will be in the double linked list. Problem would be finding out any node. Finding out any node that could be O of n. If we want to find out any of node in double linked list, that could be O of n. Correct? If somebody ask us that node with value 5 exists in this linked list or not. Node with value 5, if somebody asks us that this value exists in the linked list or not, then that could be O of n. In the worst scenario, that could be O of n, because we need to traverse everything, and then on the tail we might be able to find it. So for finding out any element in the double linked list, that could be O of n. Everyone agrees with that? Because we need to traverse whole of linked list to find out that particular element. Yes, it would be linear search. Everyone agrees with that? So for not doing that, that's why we are taking one hash map here. For not doing that, that's why we are taking the hash map here. So in hash map, we will be keeping the key would be 1, and we'll simply keep the node there, that particular node with value 5. So first, if somebody is asking us, can you find out a node or key which has value 1? So first you will find it out in the hash map. Yes, that key exists. If that key exists, you will directly take the node. You will directly take the node, and now you have the node position. Now you have the node position. You can do all of the operations. You can delete this node. You can insert something before that. Because if you reach to this node, then you can do all of the operations. You can insert something here. You can delete also here. So that's why we have taken the hash map. So now guys, everything is O of 1. Everything is O of 1 in your case. Searching also O of 1. Insertion is also O of 1, and deletion is also O of 1. Understood guys? Why I was saying that in your LRU cache, with the help of double linked list and hash map, our whole time complexity will be constant, O of 1. There will not be any iteration. Agree guys? Everyone agree here? Yeah? So let's try to implement it. Okay, please. Sir, please repeat that hash map part. Okay, Joseph. So first, did you understood, Joseph, that for if somebody is asking us that this particular element 5 exists in the double linked list, so the time complexity will be O of n. Did you understood that part? Why it would be O of n? Yes, you understood that part, right? So now what I'm saying, I will take one hash map. In hash map, what we have? Hash map or object. In simple word, hash map is like very latest word in JavaScript. We also say this is an object. So in object, we have key and value, right? So instead of, in place of this value, we will keep the node, whatever node we are creating. So first time key is coming 1, value of A, key is coming 2, value of B. So our object will look like this only: 1, node of A, 2, node of B. These all are nodes, right? These all are nodes. So we will simply keep an object or hash map of those values. So first we will directly find it from here. Now we do not need to go to linked list to find that particular node. So we'll directly find it from there. And once we find it out, that particular key, we got the node. And when we got the node, it means we have direct pointer at that node. It means Once we find out the node, it means we have direct pointer of that node. And once we have direct pointer at that node, we can do any operations because that particular node has previous address, next address, and everything. So that's why I was saying the O of 1 will be there. So we'll push all created nodes in. Yes, so while we are creating a new node, before that, we will also create the same data in HashMap. Got it, Joseph? Got it, Joseph? Yeah. So I'm not getting response from Arad. Okay, Arad has written yes. Okay. What about Parag? Parag is there? Yeah, Parag, did you understood this part? Yeah. Did you understood this part? The constant thing which we discussed? Any doubt you had? Ah, great, great. So now guys, so first let's implement our double linked list node. So let now first implement our double linked list node. So how many things double linked list node has? So double linked list node has, I think, value would be there, correct? Key, now because we are also taking the key, right? You know about the operation put 1 comma a. So we are considering this as a key, this as a value. So double linked list node will also have key. What else, guys? It will also have previous. It will also have next. Correct, guys? So now a node will have four things. A double linked list node will have four things. Or yeah, four things. So here all the previous things, previous address, then value, then key, and then next. Everyone agree with that? This would be our node. Everyone agree with that? We will be keeping value, key, next, previous, all four values in our nodes. Correct? Yeah, that's fine. Nodes got that's fine. That's fine. So let me show you quickly LRUCAS node also. Okay, so right now I'm in the LL3. 1 minute. Let me push the. Okay, guys. If anyone is not able to find the code, so all the code is whatever I'm writing, everything is available in repos. So branch is queue. Whenever we are discussing about whatever topic, that you have to go to that particular branch. I'm also trying to merge all the things in master also. So whatever I'm writing it out here, everything is available in GitHub. Okay. So 1 minute, let me push these changes also. Then I will come back to 1 minute. Yeah. Let me come back to now Q branch. So you can see now git checkout Q. Now we are in the Q branch, right? Now let's look for LRUCAS. So yeah, that's what we discussed, guys. These would be the four property for linked list, double linked list node: key, value, previous, and next. Correct, guys? Okay. Now let's discuss about our LRUCAS class. What properties LRUCAS will have? LRUCAS class, what default property it needs? So I think definitely we all are agree with size or capacity. Everyone agree with that? That this would be first field because we need to decide how much size or capacity this particular cache needed. Everyone agree with that? Recently added. Recently added which thing? Okay. What else? About after that, what else we needed here? So definitely we needed head and tail pointer. Because this LRUCAS we are implementing in double linked list. So that's why we need head, we need tail. Correct. What else? I think we can also have the count here because we need to know how many elements we have inserted. Because how we will be knowing it that how many elements we have inserted. So we will be knowing with count variable. Anything else which is coming into your mind? Head, tail, count, size, and capacity. Let me check in the chat. Yeah, hash map. Right. So we will be having a hash map also. Correct. That would be hash map also. We need to have the hash map. That's right. Anything else which is coming into your mind? I think yeah, those are. Let's see in the UI here also. So yeah, that's right. The capacity was there, count is there, head is there, tail is there, and our hash map is there. Hash map or object, anything you can say. Hash map and object. Whoever like for whom the hash map is new, just understood that the hash map is nothing new. It's just the object. It has some of the by default properties. So you guys can read about it in the internet. But hash map works in like a lot similar to object. Okay. Okay, so that was our that's all about the construction, like the basic thing which we needed. Okay, now let's jump into the operation part. The first operation is put. So we will start with put operation. Okay. So what we will do, guys? We'll create quickly two boxes here just to keep these informations. So for node, I will be creating first box. So in the node, I think we have previous. This is one field. Then we have next. Then we have value, and then we have key. Correct. And then talk about LRU. Just I'm keeping so I will not forget to increment or decrement anything. That's why I'm just simply keeping it here. Count is there. Head is there. Tail is there. Map is there. Capacity is there. Correct. So I've written all these are the 5 fields which will which the LRU cache and node will have. Okay. Everyone okay till now? Let's jump into the next part, which is creating a function for our LRU cache. Correct. Creating a function for. So we will just see one by one all the things. Okay. So let's start with size. So let's first give our LRU cache one size. So I'm giving my size or slash capacity, whatever you want to say, as a 4 or 3. 3 I'm taking. So it will be smaller. We do not need to do. Should not node have frequency field also? Why node is needed? Why node needed the frequency? Because already LRU cache has count field, but why node should have? Any thought? Why do you think like node should has frequency? Because any of node, like if there is any node, any key 3, if it is coming 100 times, that's fine. We will keep that key directly in our map. If it is coming 100 times, that's fine. It should be specific to, yeah, I'm talking about that only, right? I'm talking about specific node 3. If it is coming 100 times, how does it matter? If every time somebody is putting 100 times, doesn't matter to you, right? You have to keep that particular field in the, you always have to keep that particular key in the LRU cache memory, right? If everyone is updating, if you remember earlier scenario in the previous class, when we are trying to update any existing key, so we have to just keep that key in the LRU cache memory, and we should not be deleting it. If somebody else, some new data is coming, so we have not be deleting that one. We will be saying that it has been recently used. So that's why frequency doesn't matter. How many times same node is coming, nothing matter to us. We just need to think about it. If same node is coming again and again, it means it is recently used. Every time we have to make it recently used. Okay, Vishal? Understood now? Correct. So let's move it. So the R, LRU cache capacity is 3. So let's create a LRU cache just for visualization. Sorry for bad drawing, guys. Yeah. So let's jump into the first operation, guys, which is put 5. Okay. Put 5. Okay. So now I think we need two more things two more places to manage our hash map and linked list. So where to draw that? I think all the operation we can write here. Then we can write here about the linked list, double linked list, and here about the hash map. Are we good, guys? Here we will be writing about double linked list. And here we will be drawing our hash map just for visualization, guys. Okay. So this will be in one picture. Everything will be in one picture. Okay. So let's see. First operation is put 5. Okay. So that's the first operation. So now our linked list is W linked list is empty right now. You can see head and tail both are pointing to null, and our map is also empty. So what we will do in a hash map? First we will set. Okay. Sorry guys. Sorry for that, guys. So in hash map, first we will check is the 5 exist or not, because 5 could also be exist, right? If 5 could exist, we have to update that value. But right now our LRU cache or double linked list both are empty. So what we will do, guys, right now head and tail both are pointing to each other. So first we'll create a new node. Correct. So this new node will be created with value and key. Oh, by the way, I didn't provided the value here. I just provided the key. I should provide the value also, right? So key is 5 and value is A. Correct. So we will be first creating the node, and then because this is the first node in the double linked list, so we will be simply keeping this as a first node. And guys, I'm just keeping the key here, not the value. You know that, right? Value will also come. So I'm just keeping the key here. Previous will also be pointing out to null. Next is also pointing out to null, and head and tail will also pointing out to this. Everyone agrees there. And in the hash map, we will be putting this new node with the key 5 and node of 5. These two things we will be creating for first operation. And now everyone agrees with that, guys? This is the first operation which we will do in the linked list. First we will be creating this, and then we will creating in the hash map. Okay. So this is the first operation which we will do. Now let's talk about the second operation. If second time put is coming. So can I erase this part? Everyone got it? Can I erase this part? The first operation everyone understood. If head and tail both are null, so we just need to assign head and tail to new node. We already done it in the linked list class, double linked list class. Everyone okay with that? Joseph and Arad, what about you guys? Understood this part? The first node insertion? Joseph understood. Why value and key? Because you need to find in the cache memory, we always put two things, key and value. With key, we find it, we use key for finding out the value. It's like index. In array, we also have index, right? So these key is the indexes. Without that, you need to traverse it. Without the key, otherwise you need to linear search it for that data. But if you had key or if you know the index, you can directly access that data. So that's why always we have value and key. Understood, Likit? Which part, Arad? Which part has been confusion for you? Is it the first insertion part? Insertion one, huh? So see, right now, this is the first element is coming. So in starting, our head and tail both are pointing to null, right? Did you understood this part? Head and tail both are pointing to null. Understood that part, Arad? Head and tail both are pointing to null. Okay. So now a new node is coming, right? Understand in the linked list perspective, this is the new node which is coming. Correct? So now we have created a new node with these values 5 and A. Correct? So now we need to insert this new node into our double linked list. Correct? So because now this is the first node, so head will also be pointing out to it and tail will also pointing out to it. Correct? Because this is the first node. So head and tail both will be pointing out to that node only. Correct? Now understood? Now, and in the hash map, we taken our key as a hash map key, and this new node as a value of that. Understood now? If you guys want to see the code of this much part, I could show you that also. Okay. So let's jump into the put one. Just ignore everything else. Guys, just ignore everything else. Whatever lines I am showing you, just see those lines. Okay? Just ignore everything else. Okay, so ignore this one, ignore this one, and you can see this is the line only you need to see. This is the insertion part. So you need to go for the insertion part directly in the put method. You need to go directly here in the insertion part. And let me show you the insertion part. In insertion part, I am passing you key and value. You can see first I created a new node. I did count plus plus. Then I set, this is the hash map setting. In the hash map, I am setting my key and node, correct? And then you can see if this dot head, if head is pointing out to null, you can see this thing. If head is pointing out to null, so it means point out head to node and point out tail to node. So that's what we did. So this much line only you need to understand, guys. Understood? The first thing, understood everything now? Everyone has understood this thing? The first scenario? Anyone has any doubt? Everyone understood, right? So let's move into the next scenario. Let's move into the next scenario, guys. I'm just erasing this part so you guys can understand one node already is there. Okay, let's keep this node. That's fine. Let's keep this node here only. But I'm just removing the new node part because we already know that every time new node will be there. And just creating some space here. This would be our head. Correct. Now let's insert second value in our cache memory and second node here, which would be 6 and B. Guys, now let's, before inserting this node, try to understand one thing here. Every time, whenever we are inserting a new thing, in double linked list, that link has to be, that particular node has to be added near to head, or that particular node has to become head. That particular node has to become head. And whenever we are deleting something, from the linked list, that has to happen from tail. Whatever node is tail, only that particular node we will delete. So let's see how this will look like. So in the just visualize it first, then we will do the operation. Just visualize it. How will this happen? So now first time 4 is coming, so first node is created here with 4. Head and tail both are here, right? Now 5 is coming. So now guys, whenever new element is coming, you always make that element as a head, right? And then 4 will be here with tail. Let's insert one more element, 8. So again, you have to make this node, this new node, as a head. So always insertion will happen on the head. This will be our head. Now this would be the 5. This would be the 4. Understood, guys? And why we are doing, I will tell you. Again, do the 9 for 9 also. 9. This would be our head. Whenever new insertion is happening, 8. And then 5. And then 4. And there would be tail, and which is pointing out to null. Now, when we want to delete anything, like if we want to delete anything from here, so always whoever is in the last, whoever tail is pointing, we will be only deleting that one. So let's see. In this scenario, you can see the 4 was the first one who has been inserted here, right? You guys already know that, right? If 4, 5, 8, 9 is there, and if we got put 10, you guys will always delete the 4 only, right? Because this was the last used, or sorry, least recently used. So that's why we are making our double linked list in a structure, so that whoever element is the last used will always come in the tail. Whoever has been used last or least, that will be always come in the last. So that's why, guys, we need to do the insertion in that way only. Whenever a new element is coming, we need to add it to the head. And whenever we want to remove any element, so whatever element is in the tail, that element will be deleted. Everyone understood this funda? Is it a rule in double linked list? No, it's a rule for LRU cache, not in the double linked list. It's a rule for LRU cache, because you have already know about the LRU cache. In LRU cache, whatever element has been least used, that we need to remove. So how we will be design that? We will be designing in this way. Whoever elements is the last use, we will keep always that element into the last one. Yes, we have to go according to LRU because we are implementing LRU. Okay. It's recently added, like sir, like Redis. In Redis, actually, we do cache invalidation. We have different strategies to do the cache invalidation. So see, guys, whatever we are doing, right, the deletion part in general industry, IT industry, we have given a name, and that name is known as cache invalidation. So whatever is stale data, stale means old data or not recently used data, we need to invalidate from there. So that's what the operation which we are doing for removing it, that's called cache invalidation. So Deepak, cache, like in the Redis, I think we have different strategy to do cache invalidation. Okay. Okay, so let me read the Likhit comments also. It's recently added, so we are inserting at head. Yes, it's recently added, so we will recently added or anything which is added, whichever is added, every time it will be going to the head, and old ones will go at last so that we can delete. Yes, that's totally right. That's how we will design our solution. That's how we will be designing it. Can't we delete from head following LRU? No, we can't. We are not. We so the see, we can delete from head also, but we need to design our solution in that way. Then, if you want to delete from head, you can do that because in that DQ you can delete from anywhere. So now your solution will be different. If you want to delete from head, so always a new element, whoever is been added, it has to be added on tail. Whatever the new element has been added, it has to be added on tail, not on the head. We can go from both sides because it's a DQ. We are implementing DQ. So we are implementing DQ. So in DQ we can do operation, any operation from any side. But we need to design our solution in that way. Are we good with that? So now I am following right now insertion at head and deletion from tail. I am following that strategy. Okay, everyone okay with that? So let's move into our okay, let's keep it there like that. Okay, so now let's talk about the put 6, guys. So we need to insert it. So where we will be inserting it? We will be inserting it into head. Okay, so now if anyone remember in the double linked list how we do the insertion at head, so the same code will be working here. So now right now just visualization, guys. 5 is here, head is here, tail is here. Now we got the new element, new node, which is 6, which we want to, this element we want to make our head. So what we need to do, guys, the new new element dot next is equal to head. New element dot next is equal to head. So ये connection बन जाएगा. This connection we will have, correct? Then head dot previous is equal to new node. Head dot previous, guys, this is our new node. You guys already aware of it, right? So new node, I'm just whatever I'm just visualizing, I'm just saying that. So new node dot next is equal to this dot. So then this connection will be ready, right? Then what is else? What is now we need to make this connection also. So now this dot head dot previous is equal to new node. Okay. Now you can see 2 connections are ready. Now what we need to do? What is the next connection? I think it just we need to move our head here. So now this dot head is equal to new node. So now this head cursor will move from there to here. Head will be here. This would be 3 line. Right, guys? This would be 3 line which will make the connections here properly. Agree with that? Yeah. New node dot next is equal to head. Yes. This dot head is equal to new node. Okay. And new node next dot previous is equal to new node dot next dot previous. No. New node dot next. Okay. New node dot next dot previous is equal to new node. Yeah, that will also work. That will also work. Yes, yes, that will also work. Totally right. That will also work. Yeah, because we have already made the connection with new node. So new node dot next would be the node. Totally right. Totally right. Okay. Let's see in the code what they did. So they are doing in the here only if head is not null. So let's see in the else what they are doing. So they are doing this dot head dot previous is equal to node. So they are doing this line first. Second line they did first. This dot head dot prev is equal to new node. Then what they did, node dot next is equal to this dot head. Then they did this line, node dot next is equal to this dot head. And then at the end, this line, this dot head is equal to node. Understood, guys? Again, whenever we talk about the linked list, it's all visualization. I also do not know the code. I'll only do the visualization, whatever connection we can make. Everyone understood this, guys? Everyone understood? So now, insertion cases, we are okay. Insertion case, till 4, like whatever the size is. See, I will tell you, the problem is also there in the put. But everyone understood this part. First, let me in the chat. Arad, Parag, Joseph, Ankit, Nilanjan. Did you guys understood this? The connection, the insertion part? Understood now? Okay, so now this will happen, right? So now, yeah. So I'm just constructing my linked list here, double linked list here down. Okay, because capacity is 3, right? So let's insert 3 elements. Then we will see next put operation. So first element is here. So like I can say one more put operation there, which is 8 and insert C. So 3 operations are there. Now our cache or linked list is full. So now 8 would be the first element, right? This would be our head. Then it is pointing out to 6 because this was the second element, right? And then we will be having 5, right? And here it will be our tail, and this will be pointing out to null, correct? This will be pointing out to null. Everyone agrees here? When we will do the 3 insertion, these 3 things will be there. And I think here also 6, node of 6, and with 8, node of 8 in hash map or objects, correct? Till now everyone okay? 3 operation we did. There was in the 3 size, correct? Everyone understood? Now let's see the next thing. Now if we want to insert one more, put 9 and we'll do D. Now this operation will not happen. This operation will not happen. Why? Because our capacity is 3. Because our capacity is 3, guys. So what we need to do now? We need to delete this element from here. We need to delete. Okay, if we simply draw this, so this will look like this. First we have inserted 5, then we inserted 6, then we inserted 8, correct? So if we want to insert 9, which element you guys will remove? You guys tell me. Do not see the linked list. Just tell me in this diagram, if we want to insert something here, which one we will remove? You guys tell me in the chat. Yes, see, everyone is telling tail 5. Yeah, just tell me the answer from the array here, from the cache memory. Yeah, it's 5, right? And you can see the way we have designed already 5 is coming in tail. Already 5 is coming in tail. So that's what the benefit, guys, keeping this structure here. So let's now write the logic of deletion. So we want to delete this one. Okay, so first we want to delete this one and we want to make this node as a tail, correct? So first we need to do this simple. First operation is deletion. Insertion we will see later. Insertion of 9 we'll see later. First do the deletion here. So for deletion, what would be the logic? So for deletion, logic would be tail dot previous is equal to null. Tail dot previous is equal to null. Yeah, tail dot, yes. So tail dot previous, because see tail dot previous, ye connection. It will yeah, sorry, not this connection. Tail dot previous, when we will do, we will get this connection. So tail dot previous will give this node. So the tail dot previous is equal to null. No, 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 no. No, 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 no. 1 minute, 1 minute. Tail dot previous is equal to null. It means this node is null. No, no, no. So first take, okay. If you really want to think, so this will be little bigger, but this will look like this. Tail dot previous dot next is equal to null. This is the right thing which actually I was thinking, because इसका मुझे null बनाना है. I want to make this as a null. So how will I reach there? So I will reach first tail dot previous. It will give me this node, and then this node's next. It will give. I want to assign it to null. So now this will be, now this element, now this node will be deleted and null will be there. And then this dot tail is equal to tail dot previous. Correct, guys? This dot tail is equal to tail dot. अब ये tail बन जाएगा. Now this will be tail. And this element will be deleted totally. And we have already made the null here. That's how we do the deletion. I think I've written this thing. I'm not sure you guys have understood this thing or not, but let me see in the chat. We can implement this by Q. We are implementing Q only. Look it. We are implementing DQ only. Tail is equal to tail dot previous. Tail is equal to tail dot previous. Okay. Tail dot next is equal to null. हाँ ये भी हो सकता है. That's right. That's also right. We can use this also. Yes. Temp is equal to this dot tail, and this dot tail is equal to tail dot previous. Temp is equal to null. Yeah. Like whatever way. Yeah. That's also right. That's also right. But you guys understood this thing? Let's see in the, yeah, let me know other people who has not understood this thing. Vishal, Ankit, Parag, Arad, did you guys understood these things? How we did the deletion? We just need to come out somehow to this node and then make this node as a tail, and then we need to make this node next as a null. Correct, guys? That's what. Let's see in the chat. Let's see in the code how they have did. This will be happening on evict. So, okay, this is the scenario when head and tail. Just ignore these things. Ignore this one. Yeah, this thing is happening here. So this dot tail dot previous dot next is equal to null, and then this dot tail is equal to this dot tail. Yeah, what I write it, the same thing is written here. Tail dot previous dot next is equal to null, and tail is equal to tail dot previous. But yes, your guys will also work. Yes, I'm just shifting my tail to previous node. I'm just shifting my tail to previous node, and then making the next of that to null. Okay, Parag? So I'm just making, shifting my tail from current node because we want to delete it. Because we want to delete the 5 from there. Because we want to delete the 5 from there. That's why we did it. Understood now, guys? Everyone understood? Parag understood now? The deletion part? Okay. So now what is the next thing which you need to do? We need to insert a 9. And I think we already know the code of insertion. So we will simply insert at the top. We already know the code of insertion, right? So we will simply insert it here. Insert it here. R9. And we will make this 9 as a head. Correct, guys? And we will also delete the 5 from our hash map also. And we'll write it as a 9. Node of 9. Understood, guys? These 4 scenarios, like I think we have discussed how many scenarios? I think we have discussed 1 or 2. Yeah, we have discussed only 2 scenarios. In first scenario, we have to simply put elements till our capacity is less than the total elements. We have to simply insert it. That's the first scenario. And the second scenario was when the capacity is exceeding. Right? When the capacity is exceeding, we need to evict it. We need to delete it. These 2 scenarios, everyone understood? Anyone has any doubt? Let me know in the chat. We already do. Now, guys, we will move into the third scenario, which is get 9. or get 6, or put 6 E. If you want to update any existing key or want to get it, because once we do that, this element will become like recent used. This element will become recent use. So this 6 will no longer will be on the tail. This 6 will no longer will be in the tail. We need to move this 6 to where? You guys tell me. We need to move this 6 to where? Head. Yes, we need to move this 6 to head. This will happen in both scenarios, in get also, in the put also. If we are updating the same element, because it means when we are doing get and put for any element, it means we are using that element. It means we are using that element. Or if we are using that element, it means we no need to delete it in the next turn. We do not need to delete that element in the next turn. So how we will be saved? How we will do that? We need to move that element to head only. We need to move that element to head. So I think same operation will happen there also. So once somebody is doing get 6, so first we will get the data from here as map, and then we'll do the same operation. We'll move this 6 to here. We'll first delete the 6. Delete means we'll remove the connections, make our 8, make this 8 to tail, and then 6 will be moving here, and then we have to shift our head. Understood, guys? We must find it and remove it and add it first again. Yes, totally right, Likit. Totally right. So now you guys can think about how we were doing earlier some operations in stack, and you guys were thinking like pop and push. They are not like stack, because stack can also be implemented with linked list. Stack can also be implemented with linked list. So uh, that's why I was saying that, or you were also reading it somewhere that stack, push, and pop operations are constant time. That's the reason. If somebody is using internally linked list, so push and pop will always be constant time. Same goes for queues operation. Queues NQ and queues DQ will always be constant time operations. Because if we are using linked list, then you can see that push and pop are same, right? So guys, this was the whole about the LRU cache. Now there are, yes, if you're using linked list at the while implementing stack or and queue, the operation would be O of 1 for insertion and deletion. Okay. So now guys, this was the, I think, whole scenario. Like this was the important cases. Now there are some edge cases, like edge cases like if we have only one node and we want to delete that node. These are some of the so once we have hash map, right, sir? If we use linked list, then it's O1. Since we have hash map, yeah, since we are using hash map and double linked list, so for this particular scenario, it's for LRU cache, it's O of 1. So now guys, this was the I think all these three methods which I explained, this was only the bigger thing. Now there will be small edge cases only that we can understand with code. So let's jump into directly into code. Okay guys, do you guys thinking any other edge case, any case which we left in LRU cache? Just think about it. Anything we are leaving it right now? I think we have discussed everything. We have discussed put, like when the capacity is like when there are three elements, the capacity is 3 and we have not inserted 3. We have already discussed that scenario. Then we have already discussed about if we have 3 elements and you want to insert the fourth one, that scenario also. Then we have also discussed the get and the put, same element deletion, same element updation, all 4 scenarios. I think there will not be anything else in the LRU cache. So let's jump into the code. And we will start seeing from the put first. So let's start seeing from the put. Let's jump into the put part. So see guys, this is the first scenario. And this scenario is when we already have that key. So this scenario is this one. Put 6E, because we already have that key. So that's what in the cache we are checking. If we already have that key, so simply get that key from the cache, update the value, because we are updating the value. Earlier 6 was containing B, now 6 is containing E. So first update the value, and then we are for transferring things, right? Deleting from here and inserting here, we are using this dot use method. This dot use method. Okay, so we'll see what is happening in this dot use method. We'll directly jump into this one. This dot use method. Okay, so let's see. So first we are again getting the node from the cache while passing the key. So first we got the node. I am checking if my node is this dot head. If already the node which we are getting or updating, if that node already is head, we do not need to do anything. So that's what the first condition is. If the node is head, do not do anything. Now let's see next thing. If node is equal to this dot tail, it means the node which we are using, if that node is on the tail, so we need to delete it from here and put it on the head. So that's why you can see 3 lines of code here. So first thing, node dot previous dot next is equal to null. Same thing, node dot previous dot next is equal to null, and then this dot tail is equal to node dot previous. Same thing, guys. This is the deletion and this is the insertion on head. You can see 6 line of code. There deletion is happening, here insertion is happening. If our node is tail. Now, what is the third scenario? If my node is not tail, not head, it means somewhere in the middle. If my node is somewhere in the middle, like get 8, somebody asked get 8, we have to do the same operation, right? For get 8 also, we need to delete it from here and put it on the head. Yeah, I think I missed this case, right? I missed this case, but yeah, you guys can understand. Now that if somebody is asking get 8, this is the middle element. Middle or somewhere in the middle, middle means not head, not tail, somewhere in the middle. So what we need to do, we need to first break these connections and we need to make a connection like this, right? And then we need to bring this node to head. So that's what guys happening here. If node dot previous, so node dot previous dot next is equal to node dot next. Very easy. So if this is my node, so node dot previous dot next. So node dot previous dot next. It means we are talking about this connection. This above one. So I'm saying node dot previous dot next. Node dot previous dot next. Go there and then node dot next. इसका जो next है वो assign कर दो. Node dot next. Again visualization guys. Node dot next. Node. This is my node which I want to remove. So node dot previous dot next is equal to node dot next. So this will be the connection. Correct? This connection is ready. Now we need to make this connection. So it would be, I'm not seeing the code. So let's see. Node dot next dot previous. Correct? So node dot next would be, I will come here and then previous, right? So here what we need to do, we can simply keep node dot previous, this value, node dot previous. So you will see similar thing here also. Okay, yeah. You see node dot next dot previous is equal to node dot previous. Correct? So now this connection is made. Now this connection is there. This connection already you made it. Now what we need to do? We need to bring this node to head now. So now the next line of code are doing that. So node dot next is equal to this dot head. Node dot previous is equal to null. This dot head dot previous is equal to node. This dot head is equal to node. Same code which we did here also. You see the same code is happening here also. Same 4 lines are here and same 4 lines were there also. Correct? So this was the use scenario. Okay, everyone understood? Let me see in the chat. Everyone understood? Just the use cases are there and we need to implement code in that way. Okay, so let's see the next one. Insertion. So where we were? Oh, we were in this case. So this dot use, correct? And then we are setting into the cache. The updated value of that node we are setting into the cache. So that's what happened here. This is the scenario when we already have any existing node, we are existing key which is coming for put. So that's the scenario. Then let's look for second one. So now if any, like we have already inserted 3 elements, and if and that count is going to be greater than capacity. If our count is greater than capacity or equal to capacity, so we need to delete it. So that's why the next method is evict. So you will see here deletion again. You will see that deletion again here. Okay. Now there are also scenarios. So first you can see if tail exists, it means tail is not null. If tail exists, so just take that key. If tail does not exist, simply return it. It means there is nothing to remove. Okay. Next, if head and tail are equal, it means there are only one element which we need to evict. So we'll simply do head is equal to null, tail is equal to null. There is only one element. It means just simply remove it, remove them. Else, same thing. This dot tail dot previous dot next is equal to null. This dot tail is equal to this dot tail dot previous. It means remove the last element and do the eviction part. Then after doing the linked list, reduce your count and delete that element from the cache also. From the cache means hash map. From the hash map also. This is happening in eviction. And in the insertion, we are creating a new node. We are setting the new cache. If head is not there, if head is null, simply do the this dot head is equal to node, this dot tail is equal to node. And I think we have already discussed these scenarios, right? So I think yeah, these are 3 operations, guys. And in similar way in the get. So you can see, guys, every time we are getting from the cache, and every time we are using this dot use. Same like the put common case. When we are getting any repetitive key, we are also using the this dot use, and for the get also we are using the this dot use. That's why if you remember, get 6, put 6, we were using we were following the same funda. Key to evict. So that the key which we need to delete. The key which we need to delete, which would be always the last element. Yeah, this one always be the last element. So we are taking this key because we need to delete that key from the hash map also, right? From here. So that's why we are taking that key. Everyone understood now? I've already pushed this code in the in the queue branch, so you guys can take it from there. It was easy actually. You just need to follow the logic, and it was just straightforward. You just need to follow the linked list and hash map strategies. Anyone has any doubt? Let me know in the chat. Are we good, guys? Nobody is replying anything. Okay, doubt. If we have 5, 6, 7 and we call 6 and 7, now put 8, how code will support this? So 5 will be deleted. Simple answer. 5 will be deleted, Parag. 6 and 7, you call 6. So 6 will come to head. 6 will come to head. Then 7 you have called. So 7 will come to head. So 7, 6, 5 will be at the tail. So 5 will be deleted. So whenever you are using it, that element is coming at head, right? Whenever you are using that element or getting that element, this is the code, right? This dot use. Whenever you are using that element, you are deleting this, these 6 lines, these lines are running, right? You are deleting that a particular element from there and putting it into the head whenever you are using that part. Understood, Parag? This dot use, that is the method which is doing this part. If that node which you have used is tail, I think in your case it was because you were using that 7. So 7 was the tail one. So if you have used the tail, this code will run. If you have not used the tail, if that is middle element, which is 6 in your case, 6 was middle element, this code will run. So every time, whenever we are using any element, we are making it to head. Understood? Anyone else has any doubt? Nobody is replying. Okay, so let's see. How did you apply for PayPal? I will discuss about this in next class or any other class, or we can talk about it in LinkedIn, Deepak. Okay. Any other doubt we can talk about here? Simply about the topic which we are discussing. After doing the odd even, I got the link list. Okay. Okay. So now so key to evict code. Okay. If you have any doubt there, so let me know. Yeah. So we have find it out the key to evict. Then if our head is equal to tail, it means just make both as a null, else delete the tail element, and then delete that key from the cache as well. Okay, Joseph? Key to evict was done. Okay. So now we can move into the assignment question. Anyone tried the assignment questions? Anyone tried the assignments question? Okay, so nobody is right, so that's fine. Okay, so let's see where are assignments question. Oh, so they are not giving assignment question to you? Oh yeah, say. Oh, it's a older one. 1 minute, guys. 1 minute. You guys have assignment question, right? Let me know in the chat. No assignment for today's class. Very weird. But they have given me actually for today's class or for the previous class I'm talking about. For the linked list class, you guys do not have any assignment. They have given me, sorry, for the Q class. There was no assignment? Oh, okay. Okay, so yeah, 2 questions. Yes, that's what I was talking about. Yeah, that two question from previous class. Yes. No. That was implement. No. After that class, actually, I have the question. Let me share it. I was just looking for those questions only. One of the question is very nice there. Very like complicated also. This is the first question actually. Longest continuous. Now we'll come back to Q part for some minutes. Okay. Because these are the questions in your assignment for the Q chapter. I'm not sure these are the questions there or not, but these are the questions which has been given to me for this part. Okay. So let's see this. Very interesting question. I'm not sure how many companies has been asked, but it's little bit like tough also to understand it. Okay. Or I think there is one more easy one also. I think let's start with that. Reverse the first k element of a Q. I think this one is easy one. So I think we will first start with the easy one and then we will jump into the tough one. Okay. So these were the 2 questions. First is the longest continuous subarray. We'll see this thing. Let's jump because this one is the easy one. I think we can quickly understand this thing. So guys, see, they will be giving you one queue, 10, 20, 30, 40, 50, 70. Like this is a queue, and they are saying you have to reverse the first k elements of a queue. You have to reverse only the whatever value of k is. You can see they have just reversed starting 5 elements. So you can see 50 is coming now first, 40, 30, 20, 10, and then the remaining element 60, 70, 80, 90, 10. So let me just quickly draw this here. This is easy question, so that's why we are just trying to complete it little bit faster. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. This is our Q, right? Now, guys, I'm talking about Q. Whenever I'm talking about Q, just always think about Q only have two operations. In Q, deletion will happen on the front side, deletion will happen from here, and insertion will happen from here. So insertion will happen here, I, and deletion from happen from here. Whenever I'm talking about Q. Okay. So now what they are saying, they will provide one K value to us. One value to us, K is equal to 5. And they are saying you need to reverse the Q's starting element, whatever value we are giving here. So they have given 5 value to us, right? So 1, 2, 3, 4, 5. These 5 elements, we need to reverse it. So the final output, what would be? 50, 40, 30, 20, 10, and then the remaining element, 60, 70, 80, 90, 100. Okay? Everyone understood the question? Very easy, right? Very easy to understand. Everyone understood? Anyone has any doubt? Anyone wants me to repeat the question? Arad, Ankit, Nilanjan. Okay. Looks like recursion problem. Yeah, we can implement the recursion also. But see, we will not go that much deep. We'll simply take one stack here. We'll simply take one stack here, and in this stack, we will simply iterate till we'll simply push all those 5 elements of here to that stack. We'll simply run a loop for I is equal to 0, I less than k, I plus plus, and simply do the shift from here, q dot shift, and push it in stack. So stack dot push. We'll simply do this thing. So now all 5 element will be here, right? 10, 20, 30, 40, and 50. Correct? Correct, guys? All 5 elements will be in the stack. Everyone agree with that? All 5 elements will be in the stack. Yeah, this is like the easier one. We can think about some other approaches, but let's go with this approach first. Okay. And then what we need to do now in our queue will look like this. Because 5 element has been deleted, our queue will look like this: 60, 70, 80, 90, and 100. Correct, guys? Our queue will look like this. Our queue will look like this. So now what we can do, guys, we can pop from here, we can pop from here, we can pop from here and insert into this one, insert into this one. Correct? So let's see 60, 70, 80, 90, and 100. Correct? These are the elements. So we now will start popping it from here and inserting it back into this. So now 50, 40, and while inserting, we can do one more thing. We can, while we are inserting into this one, we can also start removing from here. We can also start removing from here and insert them back as well. Insert them back as well. Anything you want to do. See, it's very simple actually. That's what we need to simply first remove this element, these starting 5 elements, and then once we got the then we have the remaining elements, right? Then we can insert them back, these elements, like from here 50, 40, 30, 20, and 10, and then these remaining element could also be again removed from here, insert back from there. So 50, 40, 30, 20, 10, or 100, whatever the number is. What is this value? 100, yeah. And then 60, 70, 80, 90, and 100. So this could be possible, guys. This is the one way. We can just simply pop it out from here, and in similar time we can do the shifting here as well. Correct? But let's think about it. I am seeing one problem here. I am seeing one problem here, guys, which looks like let me think about it. The problem which I'm thinking with the second with this shifting part, I'm thinking a problem here with this shifting part, because uh, 1 minute. Because how we will be getting to know that this, how many element we need to shift it after inserting it. That is the one problematic here, guys. What do you guys think? What do you guys think? Oh yes, that's also there. Total elements minus k. Totally right. Q dot length minus k. Yes, yes, yes. Ah, yeah, that's q dot length minus k will give us this remaining element. Ah, totally right. Totally right. Q dot length minus k will give us this remaining element. Yeah, that's what actually not hitting me, but that's totally right. Q dot length minus k will give us this remaining element, and then we can simply shift it and again insert them back from here. Totally right. Totally right. Totally right. I think yes, you guys got it. So first we will first we will pick all those k elements in the stack, and after that from the queue we'll try to insert them back, and after inserting it we'll do loop on total element minus k and removing it and inserting it back. And that's what happening in code also, guys. Let me show you. In the queue, reverse queue first k element. Yeah, let's see it here. Yeah, I think that's what happening. You can see stack dot push q0 and q dot shift. So first all 5 element will be pushed here. All the k element will be pushed in the stack and removed from queue. Then from the stack we are removing element and pushing back into the queue. Correct? And after that you can see q length minus k. I think yeah, that was that thing I was missing. Q length minus k, and just simply pushing it everything in the queue. Q dot push q0 and q dot shift. I think this was very easy. I think just a straightforward. That's why I was giving giving attention to this question first. Yeah, please tell. It should be QI. Okay, it should be QI. This one you are saying? No. Always we have to take the first element. In the queue, we always have to take the first element. Parag, first we'll delete the 60. Then 70 will be the first element. So we'll take the Q0 again. Then 80 will be the first element. We are deleting them, right? Q dot shift will delete them. Q dot shift, this line, will delete that element from there. So always at the Q0, the next element will be there. See, Parag, we have like this 60, 70, 80, 90, 100. Okay. When I is equal to 0, at the Q0, 60 will be there. Then we are doing Q dot shift. So once we do the Q dot shift, our array will shrink. Now 70 will be the first element. So now again we have to check the Q0 only. So that's why you can read about the Q dot shift. Yes? Okay. Yeah, what was your doubt, Ekta? Okay. Okay, so let's jump into the first. Why did we not do Q dot shift and stack dot pop? Q dot shift stack dot pop. Let's see that. Q dot shift stack dot pop. So you mean here, right? But at that time we were not sure. Okay, I mean unsift. Okay, unsift mean inserted. Yeah, but that's not the how the queue work. That's not how the queue work, right? There is no operation like unsift in queue. We are trying to replicate all the operations of queue only, queue and stack. We have not tried to implement any of the arrays operations. That's why. Understood? Ekta? No, no, no. And we are trying to implement all the operations of queues, queue and stack. Because in other languages you will go, you cannot use the unsift there. There is no operation in queue like unsift. So that's why. Okay. So let's look into the next question, guys. Or do you guys want to go for break? Yeah. Suraj was thinking about it. Like I think I just resonate with Suraj's thought. So let's go for break and let's come back at 9:40. Yeah. Let's come back at 9:40, guys. Is everyone back now? Everyone had dinner? Great. So let's jump into the next question, guys. Okay. So the next is okay. So next assignment question is longest continuous subarray with absolute difference less than or equal to limit. So they are providing us one limit to us. Limit is equal to 4. And we need to first look for all the subarrays here. And in that subarray, we need to look for absolute difference. And that absolute difference in each subarray should be equal to 4 or less than 4. We need to find out those many subset where the difference is coming or, or like the maximum size of that longest continuous subarray, not the how many time is coming, size of the longest non-empty subarray. Yes. So we need to find out the longest continuous subarray where the absolute difference is less than or equal to limit. So let me first take this example in the notepad and explain you guys. Okay. So 8, 2, 4, and 7. This is our array, right, guys? And the limit which they are saying, it's 4. So first, let me come back to chat section and let me see you guys are able to see my screen. You guys are able to see my screen? It's already in the sharing, so you guys were. Okay, thank you. Okay, so now guys, what we need to do? We need to first find out the longest subarray. The difference of that subarray should be less than or equal to limit. Okay, so let's find out. Let's take create a subarray very quickly. 8, 2, 4, 7, right? 8, 2, 2, 4, 4, 7, right? And then 8, 2, 4, 2, 4, 7. What else? 8, 2, 4, 7, right? Anything else we are left with here? 2, 4, 7 is there, 8, 2, 4 is there, 8, 2, 4, 7 is there. Right, guys? Already completed all the subarrays? Let me count it from here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So we have all the 10 subsets. So now what they are saying, guys, we need to, in each, sorry, subset I'm saying, in each subarray, we need to find the difference, absolute difference. You can see longest continuous subarray with absolute difference. Okay. So now for each, in this particular, like let's take this one, 2, 4, 7. If we talk about this one, and if you want to find out the difference between these two elements, any of these two elements, right? So difference should be less than or equal to limit. So let's subtract it, or absolute difference they are saying. It means if we subtract 2 minus 4, it will be 2 only, right? If we subtract 2 minus 7, it will be 5 only, not minus 5, right? And if we difference like 4 minus 7, it would be 3 only. Absolute means no negative, always give me the positive result. That means the absolute difference. Okay, so now we need to find out a subset, a longest subarray, where if we subtract any of the elements there, then we should get a limit less than limit equal to 4 or less than 4. So let's start from 8. Let's take the first subset. There is no other element, so we will subtract, because this is the minimum, this is the maximum here. So that's why 8 minus 8 would be 0, right? Same goes for 2, 0. Same goes for 4, 0. Same goes for 7. Right, guys? Okay, let's complete it, then I will come back there. Okay, in the chat section. Then look for next subset, which is 8 comma 2. So the difference here would be 6. 2 comma 4. The difference here 2. We can consider all these also. We can consider all these as an answer. Size of array. So size of array is 1 here, 1, 1, 1. We can't consider this as answer because limit is 4 and it is increasing here. For 2, yes. So answer would be 2. Size of subarray. Answer would be 2. Look for 4 comma 7. 4 comma 7, the difference would be 3. So answer is 2. Again, acceptable. These are acceptable scenarios. Now look for 8 comma 2 comma 4. So 8 minus 4, just take the minimum and maximum. 8 minus 2 will give us 6. 2 minus 8 will give us 6. So not acceptable. 2 comma 4 comma 7. So 7 minus 2 will give us 5. Not acceptable. 8 comma 2 comma 4 comma 7. 7 minus 2 will give us 5. Not acceptable. So our answer is 2 only. This is the maximum subarray which we can get here, which has the difference, the absolute difference less than limit or equal to limit. Now I will come back to chat and did you guys understood now the question? Everyone understood the question now? What they are asking here? Let me know in the chat. Parag, Joseph, Arad, Suraj. What about the above ones? What about the above ones? Which one? Above ones, you mean the single element subarray? Single. Yeah, these are also acceptable, right? These are also acceptable answer, but size is lesser. Size is good. We need to find out the longest subarray. So those were 0 is also, wherever we are getting 0, those are also acceptable answer, but not the greater. So the longest, though not the longest. So the longest subarray which we got, these are 2 comma 4, 4 comma 7. Everyone understood now? Yeah. So now let's think about the solution. Now let's think about the solution. 8, 2, 4, 7. As you can see, in each of subarray, we are just looking for greater, like the maximum element and the minimum element. If we somehow subtract them, we will be getting the absolute difference for that particular subarray. Because see, 2 minus 8 is 6. So whatever remaining elements are here, those will definitely have a smaller difference than that. If we are subtracting maximum and a smaller one in any of the sub arrays, so whatever difference we are getting, that would be the maximum one. Apart from that, whatever the differences are coming will be lesser than that. So you can try this in this one. So like 2 minus 4 will give us 2. 2 minus 7 will give us 5. 8 minus 4 will give us 4. So that's why the maximum and minimum will be 6. All other will be lesser than that. So that's why in each of the subset, if somehow we can find out maximum and minimum, so I think we can reach little bit closer to our answer. What do you guys say? If somehow we can manage our maximum or minimum, we can reach little bit closer to our question. Correct? So let's think about it. Somehow there is something which we are maintaining with max. There is something which we are maintaining with min. Okay, guys? There's something which we are maintaining with max. There's something which we are maintaining with min. Okay. Now we are also taking 2 pointers here. 2 pointers here. Like you can give any like I or J. Okay. I or J. 2 pointers we will take. Because we need to maintain, right, the subarray. So there would be one place where subarrays is starting. I think let's give them the better name. Start and end. In the sliding window also question you guys remember, right? Start and end. I we have taken as a starting Windows position and end was ending position. end of that sliding window position. Correct? And you guys remember we were traversing all the end element. Correct? So that's what we will start. In the first position, we will be putting both of the pointers or variables at the 0th index. This is 0, 1, 2, and 3. Okay, guys. At the first time, we will be putting both at same place. Now, okay, yeah, please, Joseph. Tell me. 0 has above. Okay. Is that not minimum? Is that not 0 has above? If you're talking about these zeros, so we are looking for the sub-array size, and that sub-array size should be longest. It means maximum, not the minimum. If you are talking about that 0. Are you talking about something else, Joseph, here? 824 is max. Then 824 is max. Then I didn't understand your question. You want to speak? Anyone understood what Joseph want to try? Joseph is trying to ask here. Anyone understood? Okay, Joseph, I think you can go for speaker one, and you can talk about it, what you're asking. Okay. If you're talking, yeah. Okay. So let's once explain question. Okay. So question is Joseph. Question is, we need to find out the longest subarray where if we subtract the elements in that subarray, we should get our limit equal to 4 or less than 4. We should get whatever the difference is coming, that difference should be less than 4 or equal to 4. And we have to find out those longest subarray. So in these scenarios, solution was acceptable because the limit was less. You can see these 5, 1, 2, 3, 4, 5. These 5 are the scenarios where the absolute difference is coming less than the limit or equal to limit. But the next condition is we need to find out the longest subarray. So in that condition, only these two passes, because these two are longest subarray. So what is the size of this longest subarray? Which was 2. So that's why our answer is 2. Understood now? No problem. Yeah. So now let's think about the solution. So now we got 2 pointer here. Okay. So at the first place, put these 2 values at both place, because 8 is maximum also, 8 is minimum also, because we have only one element in the array. One, like we can consider this is the only pointer which we are considering right now. Okay. So now you can see max and min both are 0, 0. So now what we will do, guys? We'll subtract these two. 8 minus 8, because you can see in each of the subarray we are subtracting, right? Max and min. So 8 minus 8 is equal to 0. Correct? So we'll take the size this time. Answer is equal to our size. Correct? So that would be our answer. So now we can say that this is the 1. Right now our answer is 1. Answer is 1. Correct? Now what we'll do, we'll move our n2 further. We'll go this place. Again, we'll check, is this 2 is maximum than the previous element? Is this 2 is the maximum than the previous element? We will check here in the max. Is the 2 maximum than this? No. Is in the minimum, we will only check for minimum. Is 2 minimum than 8? Yes. Guys, in the maximum, we'll check, we'll only keep the maximum element, then this. Maximum element, then this. Correct? But 2 is not maximum than them. So we will not do anything here. We will not do anything here. We'll simply push it. We'll simply push 2 here. Okay? Now, in this place, because this is the minimum, so we will remove this part and we will keep 2 here. So I think now you guys have got it. What are we using here? I think you guys now got it. What are we using here? Anyone guessed it? What are we using here when we want to remove the first element? I'm talking about the first element. In a stack, we can't delete the first element. Yes, it is going to be Q only. Yeah. So let's see. Let's see, is it going to be Q or we can do with the stack also? Let's see. Let's move further. So now you can see in my min 2 is there, and in the max top element is 8. So again we will subtract it. So max 0 minus min 0. Max 0 minus min 0. So now 8 minus 2, which is 6. It means, guys, something we have here in the max or min, which is making our limit greater. You can see 6 we are getting. Our limit is 4. Something is there which is making our absolute difference greater than limit, which is making our absolute difference greater than limit. So now, guys, we will be checking with the start pointer. Now we will be checking our start pointer and increasing it further. And that's what you can see. 8,2, we got the 6 at that time. You see, 8,2, we got the 6 at that time. So now what we'll do, guys, we'll check. We'll go for start pointer and we'll check, is this start pointer, wherever right now start pointer is, that element exists in any of the arrays? If that element, whichever is in the start position, is that exist in any of these queues? Yes, it exists in the max part. So what we'll do, we will remove it, guys. We will remove it. We'll move our start pointer further and we will remove the 8 from there. So now this 8 will be deleted from here. So now only 2 will be coming at the top. 2 will be coming at top. Understood this thing, guys? Because we got something here which was making our limit greater. It means from this max or min, we need to remove one element. So for that, we will be using our start pointer. Wherever the start pointer was, I will check that, is that element exist in max or min? It will always exist. Because if start is not moving, it means whatever the element who has been inserted first, that will be in one place, even in the max or in the min. That element will definitely exist in one of the place. I'm not saying it will always exist in min or in the max. It can exist in any of the place. Okay, so that's why I moved my start there, and before moving there, I just removed that element from max or min. So now we can see. Now max and min, we got this 2, 2. Now let's look for second element. Now let's look for, move our end further. Now our end is at 4. So now we can see, we will compare it first with the max. Is this element greater than max? Max of 0? Yes, it is. So what we'll do, we'll remove this one and put 4 here. The max element. Now look for min. Is this 4 is minimum than 2? Yes, no, it's not. So I will keep 2 still here. I will keep my 2 like that. So now again, max 0 minus min 0. We'll get 4 minus 2 is equal to 2. It means we do not need to move our start pointer. Whenever we are getting absolute difference lesser than limit or equal to limit, we do not need to move our start pointer. It means this element, wherever the start is, that element is fine. It can make, like, we will not increase this element till we got any greater element, till we got any absolute difference which is going to be greater than limit. So we are okay till now. Now we'll move our end further. We'll move our end to here. Now we'll again check. Is 7 greater than max? Yes, it is. So let's remove it. Is 7 lesser than min? No, it's not. It's not. So now what we'll do? Again we'll do max 0 minus min 0. Correct, guys? Max 0 and min 0. So now we'll see 7 minus 2, which is equal to 5. Guys, 1 minute. I'm already pushing everything here also. 2, 4, 7, already pushing it. I'm not removing it, but pushing it. I have to remove only when the condition is matching, like any min is coming. I'm simply pushing it. Okay. So 7 minus 2, 5. Again, the limit is the absolute difference is greater than the 4. Absolute difference is greater than the 4. What we need to do? We have to move our start to further. So now this start will be moving to this place. And now before moving, we need to check, is this 2 exist in max or min? Yes, 2 exist here. So we will be removing 2 from here also. We will be removing 2 from here and we'll be getting 4, 7. Correct? 4, 7. Right, guys? Because we are right now we are at the 7th element, right? Right now we are at the 7th element. So now we'll move our this again further here, 4th position. Correct? Now there is nothing, so we'll not do anything in the max and min. We'll simply subtract it. 7 minus 4. I think, yeah, we can stop it here. Yeah, we do not need to go further. Okay? Or even if we need to go further, let's think about it. Do we really need to go further? Yes, actually. And if we are going further, so what we are getting? Yeah, even if we are going further, so max 0 minus min 0, because yeah, we need to check this part also, right? The last one, last subset. So that's why, yeah, 7 minus 4 will give us 3, and we can see it is still it's still less than that, so we do not remove anything from here. And our start will always be here. Our start will still be here. So now, guys, we need to do right or end minus start will always give us the answer 2. Wherever end is, wherever start is, if we subtract that position, it will always give us the size. Okay, I know this would be a little bit difficult to understand, so that's why I will take one more example. But yeah, specifically, if you guys have any question, specifically any of the places where you guys stuck while explaining the next dry run, I could go for that little bit more. Any specific area where you guys stuck? Okay, no area. So let's quickly take another example. This one, 10, 1, 10, 1, 2, 4, 7, 2. Okay, let's look for this. So max, now we already know that this is going to be our Q. Correct? Then min. This is also going to be our Q. Okay. Now let's start from here. This is our start pointer and this is our end pointer. Correct? So at the first time, both will be at this place, 10, 10. Everyone agree with that? 10, 10 both will be at the first position. Now, max 0 minus min 0. And yeah, limit. What was the limit? In this case, limit was 5. Okay. So max 0 minus min 0. So it will give us 10 minus 10, 0. Yeah. So it's still less than limit. So we do not need to move our start pointer. Whenever it is less than limit, we do not need to move our start pointer. So let's move end pointer. Now end is at 1 position. So after moving it, just check it. Is this 1 greater than this one? Greater than the max? No, it's not. Is the 1 lesser than minimum? Yes. So we'll remove this element and put 1 here. And yes, guys, we are also pushing 1 at this place also. Okay. Now 1 is here, now 1 is here. Okay, so now again do that. Max 0 minus min 0. It will give 10 minus 1 will give us 9. So now it is greater than limit. Now it's the time to remove one, move our start pointer and also remove something from here. So before moving our start pointer, just check that element exists in any of these top elements, anywhere in the max or min. Yes, it exists in the 10. So remove the 10 from there. That's why we have kept the 1 there. So now 1 is here. And start has also moved to this position. Correct? Start has also moved to this position. Now we'll move our end pointer to the next element. So now end will be moved to this place. So before moving, just check that. Is the 2 greater than 1? Yes, it is. Simply remove the 1 from here and keep the 2 here. The greater element. Is the 2 lesser than 1? No. So push it. Push it here. Okay, now do the max 0 minus min 0. Now do the max 0 minus min 0. Yes, 2 minus 1 will give us 1. So limit 5. So no need to move our start pointer. Move the start pointer now. Move the end pointer, sorry. So now end pointer at this index. Again check. 4 is greater than 2? Yes. Remove it. Put the 4 here. And insert it here also. Because it's not lesser, so put 4 here. Now again do that same thing. Max 0 minus min 0. 4 minus 1. 3. Is it lesser? Yes. No need to move start pointer. Let's move further. Move our here. Again check. 7 is greater than the max? Yes, it is. Remove 7 from here. Right? Is it the lesser? No. Push it. Simply push it. Right? 7 is there. Now again do guys. Same thing. Max 0 minus min 0. 7 minus 1 is equal to 6. Now guys, you can see it is greater than limit. What we need to do? We need to move our start pointer. So before moving start pointer, just check one wherever 1 exists, just remove it from the top element. So it exists in this array, min. So remove the 1 from here. So now 2 will be the 0th element. Okay. So now our start has moved from here to here. Okay. Now we are good. So now let's move our end further. Now our end is at this place, 2, correct? So now you can see 2 is max, then no. 2 is lesser than that, no. We can just simply push the 2 at this place. We can do, because it's not minimum than 2, right? So that's why we are pushing at the end. Correct? Now max 0 minus min 0. So 7 minus 2 is equal to 5, which is equal. Which is equal. So we will not increase our start. We will not increase our start. So just move this end to out of this. Okay. Okay. So now we do not have anything to push here. We do not have anything to push here. But just if you want to check again, 7 minus 2. 7 minus 2 would be 5. 7 minus 2 would be 5. So and then our answer would be end minus start. So I think in this case, answer should be 0, 1, 2, 3, 4, 5, 6. So 6 minus 2 would be 4. So I think answer should be 4. What is the answer here? Yeah, output is 4. I hope guys, now with these 2 examples, everyone understood how the things are happening, how we are calculating it. Everyone understood now with the logic part? Anyone has any doubt? What happened, guys? Nobody is replying anything. I know this was a little bit tough, but did you guys understood the logic? Likit, Joseph, Ankit, yeah. This is sub-array problem. Yes, sub-array is there. So we can say that, yes, it's related to sub-array problems. What about Arad? Okay, now, yes, when second example come into picture, got the logic more clearly. Okay, yeah, that's why I've taken the both examples. Thank you. What about others? Arad, Likit, Joseph, and Vishal, Parag, Suraj. What about you guys? Any place where you guys feel little bit difficult to understand? I will explain it again, no problem. Nobody is responding. What happened, guys? In this, we need to increase the end. Yes, we will increase the end. That would be like jth loop. So we will traverse all the elements. At the end, we will stop it. Need one more example? Let's see if we have one more example. Yeah, we have one more example. That's fine. Everyone okay with one more example? We can go for one more example. Nobody is responding. Yeah, let's go for it. Yeah. So let's take this one. 4 triple 2 4 4 double 2. Okay. Let's take that. 4 triple 2 4 double 2. That was right. 4 triple 2 4 4 double. Oh, one more 4 was there. Yeah. 4 4 double 2. Right. Yeah. And limit is 0 here. So it should be 0 or less than 0, right? The question is absolute difference less than or equal to limit. So anything is okay if there is 0 or less than 0. Okay. So that's what. So let's take our max cube quickly. Let's take our min cube. Correct. Let's start our start and end pointer. This is start and this is end. Okay. So let's first push 4 4 because this is the first time. So 4 4 minus 0, we do not need to move our start pointer because 4 4 0, we do not need to move our start pointer. Correct, guys? So now we'll move the end pointer further. Now end pointer is here. Now let's check. Is the 2 greater than max? No. Is the 2 lesser than min? Yes. So remove this 4 from here and put the 2 in this place and insert 2 here also. Okay, now we are here. 2 is there. So now do 4 minus 2. 4 minus 2 will give us 2 again, which is greater than limit. So what we need to do now? We need to move our start. Before moving start, just check that element exists in any of queues. Yes, it exists here. Delete it. So delete this 4 from here. Okay. Now move our start to this place. Okay. Now move our end also to here. Let's look for next. So 2. Is 2 greater than 2? No. Is 2 lesser than 2? No. So this is okay. We do not need to do anything. Just insert it. So 2 minus 2 0. Okay. We are good. Limit is 0. We'll move our end further. We'll move our end at this 2. Again, same. One more 2 here. 2 minus 2 0. Yes, we are good. So let's move from here to here. We are at the 4 now. We are at the 4 now. So now, is 2 greater than 4? No. I think all these 2 will be removed now, guys, because all are lesser. All are lesser. So now 4 will be the one which would be inserted here. Here is the 4 greater minimum than greater like lesser than 2? No. 4 will be inserted at this place. Okay. Now again, max 0 minus min 0. 4 minus 2. 2. It means there is some problem. We need to move our start. So now this start will be moved to this place. And before moving, remove the 2 from here. Remove this 2 from here. Okay. Now, again, I think we'll move our end also. Move our end at this place. So now again, 4. Yes, one more 4 will come here and one more 4 will come here because it's not greater and it's not lesser. So 4 4 has been inserted. Correct. So now again, 4 minus 2, again it would be 2. Same scenario. So now we need to move our start one more time. We need to move our start one more time. So now again, this 2 will be removed. This 2 will be removed. Correct, guys? One more 2 should be there. I think we are at this 2, right? Yeah, we are at this 2. Yeah, fine. We are at this 2. Correct. So now we will move our n to one more here. So now again we'll see for 2. Is 2 greater than 4? No. So insert it here. Is 2 lesser than 2? No. So insert it here. So now we'll see 4 minus 2. 4 minus 2. Again there is some problem. 4 minus 2. Again there is some problem. So 4 minus 2 is equal to 2. So now we need to again remove this 2 also. This 2 will also be removed. And now start will move to this 4. Correct? Now let's move our n to here. Correct? Now let's check. 2 greater than 4? No. So inserted it here. Is 2 lesser than 4? Yes, it is. So remove all 4 from here and just take these 2, because 2 is not lesser than also. So it will fail here. So one more 2 will be inserted. So 2, 2, both are here. So now again check 4 comma 2. 4 comma 2. 4 comma 2 will be minus 2 again. Again we need to move our start pointer, guys. And before moving, remove this 4 from here. So now this 4 will be removed from this place. And our pointer will reach here. Our pointer will reach here. And now we'll move our this to last element here, where we do not have any other element. So now if we see 4 minus 2, 4 minus 2. So once we are at this place, we do not need to do anything, right? We are at the out of our loop. So we'll simply subtract n minus start. So n would be at 0, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 5 will give us 3. That's what we are doing everywhere, right? Here also 6 minus 2. That's wherever we reach here, we just subtract it. Same here. Correct? So that's what we did there. 8 minus 5. Everyone now feeling a little bit comfortable with this question? Okay, no problem. Everyone now feeling comfortable with this question? Nobody is replying anything. Ankit has said yes. Okay, nice. Joseph is saying yes. Output is 3. Yes. Arad is lost. You have to watch the video again. Lost. Yeah, that's fine. What about others? Who was left? Suraj, Likhet, Vishal. Are you guys still here? Deepak, Ekta. Not sure you guys are still here or not. Okay, so let's see the code of it, guys. Let's see the code of it. Different subarray. Yeah, this one. Okay, so you guys can see we have taken 2 arrays for storing the max and min. Correct? We have taken 2 pointers, left and right, and we are taking one simple variable num just for fetching out the values. Okay, now you can see first we are taking the value. So I think this line would also be written like this: right is equal to right plus plus, or you guys already know about that, right plus plus. First we take the value from there. I think same we can do here also. Otherwise you guys will be a little confused. Left is equal to this, and then we can do left is equal to left plus plus. Oh, left plus plus simply. We are incrementing our plus plus plus. So yeah, so first we have taken the zeroth index value. You can see here now. Then we are incrementing our right, like this right pointer. Removing and adding element is it similar to our subarray problem? Removing and adding, is it similar to a subarray? No, no, no. It's different. In the subarray problem, which we did last, if you guys remember, we did two problems in subarray. In one problem, we were doing the subarray minimum, and in another problem, we were trying to find out the range. So in that case, we were doing the next greater element or previous greater element, next lowest element or previous lowest element. That logic we were applying there. Correct? Not that one, the one we did in last class. The one we did in last class. 1 minute, let me go to here. Which one you are talking about? In last class, we did these 5 questions. Non-window, non-repeating character, window maximum, and LRU cas. Oh, sliding window. Oh, you mean slide? No, sliding window, it's little bit different than that. Little bit different to sliding window. But in one way, you can say that it is creating a sliding window. With these 2 pointers, you can see we are creating a small sliding window here for our subset. Yeah. But yeah, it is using min on max both at the same time. So that's the little bit the difficult part. Yeah. So let's see guys here. So now first we got this value, and then you can see while max dot length, if there is any element in the max, so just simply remove everything from the max and remove everything from the min. If it is not, num is not greater than max and num is not less than min. The same thing, right? Which we are doing in the max and min. But 1 minute, guys. I think they are doing pop. So they are doing pop here. Will the pop will also give us the same answer for the max and min? Will the pop will also give us the same answer? Let me think about it, guys. 1 minute. If they are doing the pop and they are doing in the while loop, then we find out the num which is greater than. So will the pop will also give us the same result? 1 minute, guys. They just written the pop there. So let me think about that also. 1 minute. Quickly, let's 4 right? Then 2 is coming, so it will be popping. Okay, for the first element, pop will be same. So 2 will be here, right? And then now 4 minus 2. So we need to remove this one. So the 4 will be removed, and 2 will be inserted. Yeah, 2 will be here also, because 2 elements we have inserted. 2 will be here. I think in this question we will not be able to understand properly. Let's take this one. 10 1 2 4 7 2. 10 1 2 4 7 2. Quickly understand that pop will also work or not in similar way. Yeah. So max and min. Correct. Our pointer is here. 10 10. We are good. Let's move this to 1. Remove this. This is 1. This is 1. Okay. Now 10 minus 1 is equal to 9. Limit was 5. So remove 10. Remove 10. Now 1 is there. From here also 1 is there only, both places. Let's move our start to 1. And let's move our end to 2. Right? Now again check. So 2, is it greater than max? Yes, it is. So again we are doing the popping. So once we do the popping, last, it's only one element, so nothing to pop. So last element only 4. What about here? Let's push here 2. Okay, so now 2 minus 1, 1 is fine. Let's increase our pointer here to 4. Again, it is only having one element, so nothing is happening here. We are not able to understand like pop will work or not. Then I think 4 minus 1 is equal to 3. 7 will be here. 7 minus 1 is equal to 6. 7 minus 1 is 6. 1 will be removed. 7 minus 2 is equal to 5. I think in this example also we are not able to understand the pop part. That pop will also help you or not. Let's try with this only example. 4 2 triple 2. Do you guys have any suggestion for that? The pop will work or not? I was going with shift. What do you guys think? Pop will also help us there. I need to find it out that thing. So 4 triple 2 double 4 double 4 double 2. Right? So let's create quickly max and min. Right? Okay. Yeah. So start is here, end is here. In meanwhile, if you guys have any thought on that, let me know in the chat. Okay. So 4 4, we are good because our limit is 0. Okay. So we'll not do anything. Now we'll move our end to further. Just checking that pop will work or not. We are 2. So now 2 for 2, it's not maximum is fine. We'll insert the 2 here. But for the minimum pop will happen, we'll put the 2 in this place. So 4 minus 2. Here we are definitely removing the first element. When we are moving our start pointer, we are definitely moving the first pointer because otherwise there is no other way. But let's look with the let's look for the starting one. Okay. Now 2 is there, which is smaller. Nothing matter. Nothing matter. 2 is there. Okay. And 2 minus 2 is 0. Just move this one here. Same goes for this 2 also. Nothing matter. Now let's look for 4. This one is interesting. So for 4, yeah. Oh yes, actually pop will also remove all the elements. Pop will also remove all the elements, guys, and then we'll get the 4 here. Pop will also remove all the elements, and then we'll get the 4 here. I think pop will also work, guys. Then we'll get the 4 here, and then 4 minus 2. From here, definitely 2 will be removed. 2 will be here. Then this 4 will be here. Again, 2 will be removed. Again, this 2 will come here. Start pointer will come this place. And now this 2 will come. Nothing matter. 2, 2. Okay. 2 minus, yeah. 4 minus 2 is equal to 2. This 4 will be removed. Yeah, guys. Pop will also work. In this place, max.pop and min.pop will also work. We have already checked it out. If we are removing on the front side or from the back, I think pop will also. Is it triple 2 is making output as 3? Right, in last example, it's triple 2. Yes, triple 2 is also making the answer. Yes, triple 2, you can see, right? Triple 2 size is 3. So 2 minus 2 is 0. 2 minus 2 is 0. So triple 2 will definitely be one of the answer. Okay, Parag? Triple 2 will definitely be one of the answer. Yeah. Let's move into code. Yeah. So you can see, after checking all these things, we are simply pushing those elements. We are also trying to do that also. And then max minus min, max 0 minus min 0. We are checking with the limit. Is it less than equal to limit? If it is, continue this. Continue this, all these things. Till we got the less than equal to limit, continue all those steps. Whatever we are doing. Continue all those steps. If not, if if the max 0 minus min 0 is greater than the limit, then guys, you can see I'm taking the element in left and then I'm comparing wherever in the max 0 or in min 0. Simply shift. Simply doing the shift. So guys, this max, you know, yeah, I think this is working as Q only. Yeah. Because we are doing the pop and we are doing the, but yeah, no, actually this is working as a DQ, guys. This is not the Q. This is working as a DQ, right? Because in the Q, we can't do the pop. In Q, we can't do the pop. So that's why this is DQ problem. Because in this DQ, we are also doing the popping as well and from the back side, and we were also doing the shift from the front side. So we are doing deletion from both sides. So that's why it's not Q, it's DQ. And then you can see, I'm just increasing my left pointer. So whatever I explained with the 3 examples, same code is written here. Okay. And then you can see, because I'm already doing the right plus plus. So that's why always my right pointer will be at the last position. After reading the elements, I'm just doing right plus plus. That's why all at the end, when the right will be stopping, my right will be at the outside of index. So that's why outside of index 8 minus 5, I'm getting the answer. Understood, guys? Any doubt? Yeah. What is your doubt, Parag? If you're talking about the earlier question of yours, yes, that is definitely making the answer. Tuple 2 is definitely making one answer. Yeah. Last example. If you are talking about the tuple 2, yes, that is definitely making one answer. Raising hand. Okay. You want to speak about? Yeah, please go for it. Yeah, Parag. We can hear you.
Hello, am I audible?
Yes, yes, you are.
Yes, sir. So, sir, जो last example था अपना,
हाँ. This one,
तो
right?
जो 222 का जो combination बन रहा था,
Correct.
है ना? तो ये अपना required answer था, है ना?
This could be required answer, yes. Or let's see, 4 4 can't be, 2 4 4 can't be. Yes, tuple 2 would be only the answer. Yes, totally true.
सर,
Right.
तो अपन जो लास्ट में गए थे, जो अपना एंडिंग पॉइंटर था, जो लाइक 8 पे पॉइंट कर रहा है अभी, एंड जो स्टार्टिंग वाला है जो अभी 5th पे कर रहा है,
हाँ.
तो इससे कैसे निकलेगा फिर?
नहीं,
क्योंकि
हम ये नहीं निकाल रहे हैं कि हमें सबसेट कौन सा चाहिए. हम ये नहीं निकाल रहे हैं कि हमें कौन सा सब एरे चाहिए. बिकॉज देखो, जब हम वी वर कैलकुलेटिंग द ट्रिपल टू साइड, एट दैट टाइम वी हैव मेड द गैप. We have, because we are creating a window, and that window is going to be continuously till the last element. So we are not calculating which sub array has given us the answer. Okay, so that's why we have created one window, and that window, whatever gap that window has created, that gap is going to be in the similar way till last element. So that's why we are checking all the windows. We are
okay,
moving that
so
window.
like we are checking all the window and then concluding that the the like sub array of 3 element is the required answer.
Yes, it would be required answer.
So like where we storing that number, like suppose if we are at the initially we having 0, so we will store x 0, then we encounter with there is another element who having like in an array there's an 3 element, so we'll
Correct.
store 3, right?
No, we are not storing that thing. We are
Then
not storing that thing. We are just finding out with the pointers wherever the pointer will be. Whenever we have traversed all the elements in the array, the element which is provided, wherever our end pointer and wherever the start pointer, the difference of that will give us the size, because that's how we are traversing them. You can see with the max and min, that's how we are traversing them. Always see, first time if we got the minimum element here, we are not moving it further. It means that that element is going to contribute. You can see we are
yep,
only moving
correct.
start.
Hmm.
We are only moving our start pointer. Then when we are finding that this element is no longer contributing to our limit answer, then we are moving this pointer to the right side. if
Correct.
if this element is continuously contributing, like if I say all the elements are 2 to 2, this pointer will not increase. So then you will say that the largest size would be 8 minus 2 would be 6. Understood? So this is start pointer, and this end pointer is the one who is giving us the difference.
Okay, got it,
Yeah.
that's the difference giving the output.
Yes, giving us the
Yes,
answer.
yep, got it.
So I'm not getting proper response from from you guys. Can you guys tell me what happened? Did you guys want me to explain anything again? I know this was little bit difficult to understand with the max and min. Okay, need to spend some time with code. Yes, yes, definitely. I missed it after break. Ah, okay. Okay, your internet connection is crazy. Okay, but got the approach. Yeah. What about you guys, Deepak, Likit? You guys are also facing some problem. Joseph. Okay, sure. What about other guys? Arad has joined late. Vishal was like missed it. So Vishal and Arad has to see it later. What about others? Suraj, Deepak. Okay, so nobody is responding. So I think they might be having some internet connection. Before write the codes, better to write the paper. Yes, definitely. That's the way actually the interviewer also thinks. Okay, so let's move into guys today's topic, one of the linked list problem. Okay, we'll quickly see the one of the linked list problem, and in next class I will ask to Ansul to have give us one session to solve all the linked list problem. Okay, guys, and I will request to you guys everyone that in the before joining the next class on Friday, I believe that would be our last class also. Please solve all the problems of queues, and also solve all the try like at least try solving all the problem of linked list with assignment, because in that class we'll try to solve the all the linked list question as well as the assignment. Okay, guys, so let's look into the first question of our linked list. I think that would be easy. So what is happening here? They are saying, guys, they have given us one sorted array in the linked list, and we have to remove the duplicate element from it, right? So now you can see 1, 2, 2, 3, 3, 3, 4 is there, and they are saying us that we need to remove the duplicate element from here. Let's think about it. Let's quickly jump into the linked list approach. So we have 1, 2, 2, triple 3, and then we have 4. Correct? And we need, this is our input, and our output should be like this: 1, 2, 3, and 4, and null. Right, guys? That's what the output they are looking for. Let me see where I can see. Yeah, 1, 2, 3, 4. Yeah. Everyone can see my screen. Yeah. So, any suggestion? Anyone wants to give any quick suggestion for this? Any visualization? Anything coming into your mind? Get duplication means? Duplication means duplicate elements. You can see 2 and 2 are duplicate. 3 and 3, 3 are duplicate. So we are going to remove those duplicate elements, and we are going to keep unique element on those duplicate. Okay, Vishal? Yes, Ekta has given right answer. Compare node.data to node.next.data. Okay. You mean one node is pointing to itself? No, no, no. The values of node. Vishal, I see. The values of node should not be duplicate. Values of those node should not be duplicate. That's the meaning of duplicate nodes here. Okay. If same node dot next is equal to node dot next dot next. Totally right. Ekta has given totally right answer. So that's what, guys, we are going to do that. We are going to compare. So see, we will start with this node. Let's write it. We'll write all the nodes again. Yeah. So we'll start with this node. Let's give this node as a temp. Correct. We can keep keep our head into temp, right? And then what we'll do, temp dot data. I'm saying like this value is because in linked list it's a single linked list. In single linked list we have two things only, data and next. Correct? We have only two things. So temp dot data is equal to temp dot next dot data. Temp dot next dot data. Correct? And we will put one while loop here. And we're looking for temp dot next is not equal to null. Is not equal to null. Till that, continue this loop. Correct? So what we are doing here, if temp dot data means is node ka data of this node, is it equal to temp dot next dot data? It means iska next kya hoga? Ye element temp dot next is this. So is this data or this data, is it equal? If it is equal, so then assign temp dot next is equal to temp dot next dot next. If it is same, if data is same, so जो भी इसका next है ना उसको assign करो. You can see temp dot next. Iska next. See guys, this is just linked list. This is just the visualization part. Let me show you also. So one has two things, value and next. Next is pointing out to this node, which is 2, and then next. Correct? Which is again 2. Right? So now what I'm saying, if if this one and this one, if those, okay, let's move to this one. This 2 and this 2, if they are equal, you can see this is my temp. Right now, temp is here. In this case, 1 is not equal, right? So that's why I'm taking this one. So I'm just trying to explain this condition, guys. Trying to explain this condition. So temp dot data, this part is saying mean temp dot data. If it is equal to temp dot next, it means this temp dot next dot data. It means if it is equal to this data, then simply update this next. So temp dot next is equal to temp dot next dot next. It means temp dot next dot next, which would be 3. So temp dot next would be 3, and then this connection, the new connection we will make, and this connection will like this. We'll break this connection and we'll make connection like this. So that's what is happening here. Temp dot next is equal to temp dot next dot next. Else, if this is not the case, if temp dot data is not equal to temp dot next data, like first scenario, 1 and 2 are not equal, simply temp is equal to temp dot next. अपने temp को बढ़ा दो आगे, temp dot next. These 4 line only, guys. These 4 line you have to write. Your code is done. So you can see that. Let's dry run it. Quickly. Let's dry run it. Okay, so let's start from here. Temp is starting from here. If temp dot data, which is 1, is equal to temp dot next dot data? No, it's not equal. So move our temp further. Move our temp to this position. This is this else part which ran. Okay, now our temp is this place. So temp dot data, which is 2, is equal to temp dot next dot data. Yes, it is. So what we need to do? Temp dot next, इस next को update कर दो, इस next को अब इससे जोड़ दो. Temp dot next is equal to this. Now this 2 has been removed from here. Correct? Now this 2 has been removed from here. Again check into the same condition. See, I'm not moving my temp anywhere. Again temp is here. You can see again temp is here. So again I'm checking same thing. Temp dot next is not equal to null. Yes, it's not. Again temp dot data means 2. Is it equal to temp dot next dot data? It's not. Now go for else part. Now move our temp from here to the next element. Here, now our temp is here. Again check. Temp dot data is equal to temp dot next dot data. Yes, it is. If it is, break this connection. Break this element and directly point it out to the next element. Again, we are again temp is here. Temp.data is equal to temp.next.data. Yes, it is. Again, break this one and make the connection with next one. Again, break this one and make the connection with this one. Now again, temp.data is equal to temp.next.data. No, it means move our temp to next element, which would be this one. And now temp.next is equal to null. Our while loop will stop. And now we will get the final result at 1, 2, 3, and 4. Understood, everyone? I hope this was easy. Everyone understood now. Anyone? Joseph, Suraj, Ankit, anyone has any problem here? Arad? Got it? Everyone got it? Parag? Anyone has any doubt? Got it? Okay. So guys, if you want to see this this code also, so you need to move to LL3 branch. Git checkout LL3. In this branch, you need to go, and you have to go into the linked list folder. In the linked list folder, there is, I think, duplicate.js. Yeah, duplicate.js is there. You can see the same code. First, I am checking some of the, and you can see this is the lead code problem. So in the lead code also, you can see this thing. And let me merge all these things into the master branch. What is happening here? Difference dot. Ah, okay, those lines. That's fine. Okay, so sir, first quickly see the code, then we'll see the other things. So duplicate.js, yeah. So you can see I have taken my head into temp. Whatever I told you, temp.val is equal to temp.next.val, temp.next is equal to temp.next.next, else temp is equal to temp.next. Same code, whatever I explained you there. Okay. So quickly, let me push all the changes. First, let me go back to Q branch. And first add this difference. Git commit -m change in sub array. Git push. Okay. Now I am bringing everything to master also, guys. So git checkout master. Git rebase Q. Successfully rebase. Git push. Everything we have pushed. Now let's go back to LL3 branch, linked list 3. Okay. Now bring everything from this branch also to master. So git rebase LL3, successfully rebase here also. Git push. Okay, git push -f. Yeah. So now guys, you guys can see everything in the master also. Okay. This was a duplicate code. Could you share the achieve log n for this one? Can we achieve log n for this one? For this one, achieve log n. Let's see the time complexity here. So we are definitely traversing whole the elements, but without taking extra space. Would be difficult, right? Would be difficult because without traversing all the elements, you will not able to find it out that this is the duplicate one or not. How click login, whenever we talk about login, it always go to the binary search, right? Whenever we talk about the login, it goes to binary search, and in binary search we just, what we do in the binary search, in the binary search we just cut whole array into half of array, and then we divide it into again into half array, right? So but here I don't think we can divide our linked list. I think we need to store values in it. But yes, storing is again traversing, right? If you are storing a linked list values, it means you have to traverse it, the whole linked list. And when you are traversing it, why not do the same at the same time? No, that's fine. No, no, not a problem actually, Vishal. This is good actually. You're thinking about it. That's very nice. No problem. That's good. So guys, those code are there. Who was asking about the repo? Ankit. I already shared it many times. So let me share it again. GitHub.com, DSLGO. Spelling is wrong, by the way, guys. And you can see in the master code, because that's what I'm saying. In the master branch, I have posted everything. Otherwise, you guys can go to the Q branch, right? You will see everything here also. In the LL3 branch, you will see all the linked list. All the linked list thing we'll do in the LL3 only. Okay. So let me share the repo with you with the master branch. Otherwise, you guys will face difficulty. Yeah. Okay. So let's quickly see the second code also. Okay. I think we have 10 minutes. So I think we can discuss the approach for second code linked list. So I'm requesting guys, please everyone, because we have already covered the linked list. So I'm expecting everyone to complete all the linked list problem here. Not complete, just try it out. Okay. Now see this problem. They have given us two sorted linked lists, and your job is to merge them in a way such that the resultant list is also sorted. So you have to sort the linked list in a way, you have to merge these two linked lists in a way that the resultant linked list should also be sorted out. Okay. So let's see that quickly. So the first linked list which they have provided, which is 1, 2, 3, 4, and pointing out to null. Okay. Then the second linked list which they provided, that is 1, 4, 5, and null. And guys, these all problems, I think all 5 or 6 problem, whatever you have, all problems are available in the lead code. All problems are available in lead code. Okay. So let's think about it. This one. So now they are saying our final output is this: 1, 2. I think 1, 2, right? No, no, 1, 1. Sorry, we do not need to. We can have the duplicate also. So 1, 1, 2, 4. No, no, 3. Okay, 3, 3, 4, 4, and 5, and yeah, actually, yeah, it is sorted order. Sorry, I forget it. So we need a linked list. After merging all these elements, we need a linked list which should also be in the sorted order. Everyone understood the question now? This is the two sorted linked lists they have given, L1 and L2. These are sorted also. Okay. And now they are saying we need to merge these linked lists. And after merging these linked lists, we should also get the sorted elements here. Everyone understood? Without taking an extra space. Yes, without taking an extra space. Okay. So let's think about, guys, what we can do. We can start traversing from this linked list. Okay. So we can start from any one of the linked lists, and wherever we first got null, we will stop there. We will be stopping at that place wherever we got the first null. So let's start from this linked list. Okay. Or might be from this anyone we can take, no problem. Any linked list we can take, but I think this one is the smaller one, so I think we can start. No, I think start from this only, the first linked list. Okay. So let's take one temp variable here. Let's take a temp variable here, and let me 1 minute. Let me also check. Let me also check in the lead code that we have to take a, like, what is the constraint they are giving? Any constraint which, because in some question they are saying that merge duplicate. No, no, no. This one, merge two sorted lists. In some questions, I have seen that they are giving us. They're giving us like we have to take the new array. So we can see 1 minute. Let me just remove the code from here. So you are given the heads of two sorted linked list, list 1 and list 2. merge the two lists in a one sorted list. The list should be made by splicing together the nodes of first two lists. Return the head of merge linked list. So guys, they are saying the list should be made by splicing together, right? So I think we can what we can do, we like at the end our list one and list two should not be changed. I think that's what they want to say here. The list should be made by splicing together the nodes of first two lists. But I think if we talk about the splicing, then I think it makes sense, like we can divide our linked list here, but that's fine. Let's not think about that. We can think about in and like let's start first merging these linked lists. If you guys remember the last code when we were merging two linked lists, right? In the last time when we were doing the merging the two linked lists, so we have taken one pointer temp, and that pointer was just storing all the next values, and then we were trying to add it. So like see, if we take this the same linked list again, 1 2 3 4 null, and 1 4 5 and null. Okay, so now it will, this is linked list 1, this is linked list 2. So we have taken one pointer which is pointing out to null first, right? Now this is the I can say this is L1 pointer and this is L2 pointer. I've just taken my head in two different pointers. Okay, so now what would be the first thing I will do? I will take in the temp is equal to L1 dot next. So all the next element of L1 will be pointed out to temp. So now temp will be this place. If you guys remember the last code of merging, that's what we did. We have taken one pointer which was pointing out to all the next element. Now what we will do, L1 dot next is equal to L2. L1 dot next is equal to L2. This one will be pointing out to this one. Correct? L1 dot next is equal to L2. So guys, this is the case where we are going to change internal, like we are going to change the L1 and L2. In this way, we are going to change the L1 and L2. Okay, there could be another way also where we do not need to change L1 and L2. For that scenario, we need to create a new linked list, and in that linked list, we need to start adding the element. But that way you can think. But this one, let's first talk about this way. So now one and one is there. Now L1 will point to temp. Correct? So now this L1 will move to this element, temp here. Now L1 will move to here. Now we'll do the similar thing for L2 also. So temp is equal to L2 dot next, or L2 dot next is equal to L1, and L2 is equal to temp. Same code, if you guys remember about it. Same code we did. So once we'll do temp is equal to L2 dot next. So temp will be now pointing out here, this element. Then L2 dot next is equal to L1. So after this one, assign this 2. Correct? You remember this code, guys? We have done in the merge sort, this part of code. But there is one more thing actually, guys, which I am missing here. And that is, I think we need to compare the values also. We need to compare the values also. And based on comparing, we need to do all these steps. We need to compare the values also. Like see, L1 dot value, when L1 dot value is greater or equal, than the L2, like in the 1 and 1, then I think this is fine, right? And same I think goes for 2 and 4 also. But I think in one place, I think 3 and 4. Let me think 1 minute. So after 2, yeah, 2 is there, correct? And then L2 will be moving here. L2 will be here. Yeah, you can see after 2, 4 is coming. After 2, with the, if we go with this logic, 3 3 6 line, then after 2, 4 will come. But that's not the needed one. That's not what we need. We need 3 there. So that's why we need to apply this condition also. And based on this condition, we need to put this logic there. Okay, guys. So I will leave this to you to think about it. But yes, we can approach with this way. And there is one more way actually. There is one more way where if we do not want to change, if we do not want to change L1 and L2, we can create a new node. We can create a new node, and then we can start assigning these elements directly to that node based on comparison. Based on comparison. So see what we will do. L1 dot val. If L1 dot val is greater than L2 dot val, then in this node, node dot next is equal to L1. Node dot next is equal to L1. If not, then node dot next is equal to L2. That's what. See, guys, let me tell you. We will create one dummy node here. Okay, and we are pointing this dummy node with temp. So now, in this condition, when L1 dot val is equal to greater than L2 dot val, what we will do? We will be going for temp dot next is equal to L1, and then temp is equal to temp dot next. Correct? So now L1 will be added here as 1, and now our temp is this place. Correct? Now we'll again look for else. Again look for one more if condition. If L2 dot val is greater than or equal to L1 dot val, so we'll do again temp dot next is equal to L2. So now after this, one again will be added. So that's how we'll go continuously on this loop, and then our all element will be added. So these are two approaches. I will just give these two approaches to you guys. Think about it, and let's join back in the next class. And there we will discuss about these both approaches with little bit deeper. Okay, guys. So I hope you understood both approaches, and we'll come back on next class. Anyone has any doubt? And yes, please start practicing it. In these linked list questions, I am expecting these questions should not be difficult. Whatever we have covered earlier, I'm sure like these questions would be easily solved with those approaches. If not, we are going to discuss in the next class. Okay, guys. So let's wrap it today. Wrap it today's class, and let's connect back on next day. I hope you guys have understood some of the problems. I think LRU CAS was the easy one. We have already understood that one. And then I think Q insertion in Q with like reverse kth elements in Q. That one was also easy. Then we jump into the sub array minimum. That problem was little bit difficult. So you guys face little bit problem there. But we have spent good times. We have spent good time on that. We have spent like I think more than half an hour on that question, or might be near to 1 hour, with all the examples and code. And then we have seen one first linked list question also, which was finding out a duplicate element. And then we were looking into this one also, where we have to merge two sorted linked lists. So I hope you guys have enjoyed the class. And in next class also, we are going to do the problems only. Okay, guys. So let's wrap it. Have a good night, guys. Bye-bye. Thank you. Bye, guys. Bye-bye.